Welcome to Learning TypeScript course, section 2, Building Advanced Functions. In the previous section, I've introduced you into TypeScript. In this section, we'll go further and we'll learn and do a bunch of examples in depth with functions. In the first video, we'll start working with functions where we'll cover function declarations and expressions, types, optional parameters, and so on. In the second video, we'll cover callbacks and arrow functions. Following that, we'll explore higher order functions, where we'll create our own higher order function. In the fourth video, we'll cover promises and generators, and in the last video, we'll work with async and await. So in this video, we are going to focus on function declarations and expressions, types, optional parameters, default parameters, REST parameters, and generics. So let's get started with function declarations and expressions. You should be familiar with function declaration and expressions while working with pure JavaScript, but if not, it will be for you a very quick reminder. First, I will show you these two functions. So I will create a function declaration. So obviously a function keyword, then a function name, for example, get name, and it will return a string, for example, John. Now I will create a function expression. So the first thing we are going to do is a variable called getNameExpression, which is equal to an anonymous function. And it will also return a string, for example, John expression. These two functions are really similar, but they will behave differently. The interpreter can evaluate a function declaration as it is being parsed. On the other hand, the function expression is a part of assignment, and it will not be evaluated until the assignment has been completed. So for example, if I call getName before its declaration, it will work. If I call a function expression before its declaration, it will prompt an error. You may think why. It's a process known as a variable hoisting. As you may already know, hoisting is a JavaScript mechanism where variables and function declarations are moved to the top of their scope before code execution. So in that case, we are calling the undefined. Function types. In the previous section, we have learned that we can create a type variable by adding optional declaration annotation. For example, let age, which is a number, is equal to 26. We can also use types in our function. First, let's take a look on the slide where you will see an example of basic function definition. As you can see, we can provide types in a function parameters. Also, before a function body, we can put a function return type. So let's say we want to create a function addName, which takes one parameter, name, which is a string, and return an array of strings. Before a function, we can create a variable called names, which is an array of strings, an empty array. And in the function body, we'll push that name to names and return names. So first, write names.push name, and let's return names. And now if I call addName, then provide John and Sam, we can console.logout and click run. And on the console, you will see that we log out an array of John and Sam. Function optional parameter. Unlike JavaScript, TypeScript compiler will throw an error if we try to invoke a function without providing the exact number and type of parameters that its signature declares. For instance, if we call addName without providing the string, so it will occur an error. But there are some scenarios in which we might want to be able to call a function without providing all its arguments. So if we want a function parameter to be optional, all we need to do is add a question mark next to the parameter name. And as you can see, there is no error. Function default parameter. When a function has some optional parameters, we must check if an argument has been passed to the function. There are some scenarios in which it will be more useful to provide a default value for a parameter when it's not supplied than making an optional parameter. For example, if we don't pass a value to the function name, we'll contain a John value. In order to do that, all we have to do is provide equal character after the type in a parameters, then for example a value John. So in that case, if I add a name without providing an argument, if I console.logout and run it, I should see in the console an array of 3 strings, John, Sam, and also a John. Function rest parameter. As you can see, we increased the number of ways that we can invoke a function. The rest parameter syntax allows us to represent an indefinite number of arguments as an array. So for example, we can refactor our addName function. So instead of creating another and another parameters, we'll replace a name parameter with 3 dots. Then we have to provide the name of a parameter. So I will change that to the name array, because as I mentioned, it represents an indefinite number of arguments as an array. So it will be an array of strings. Okay. So in that case, we can iterate through an array. So I will change the logic in the function body. In that case, we have to write name array for each and then type function, which takes a name, and we have to push to names a name, just like that. So now we can invoke addName and provide a couple of parameters, for example, John, Sam, and Will. And if I console.logout, there is an error. Oh yes, because we have to return name array names. Okay, and let's run it. Yes, and in the console you should see an array of 3 strings, John, Sam, and Will. The default and rest parameter are available in AS6. Generics. Andy Hunt and Dave Thomas formulate dry, don't repeat yourself principle in the book The Pragmatic Programmer. This principle aims to reduce the repetition of information of all kinds. First, take a look how the basic generic function definition looks like. As you can see, we have to specify one additional thing when we are comparing to the basic function, and it's an angle brackets with T character, which is used to refer to a type. It's also called type markers. This type can be used in parameters or as a function return type. Now let's create an example. If you want to call toString method for each primitive type, we can write number toString, and then for instance string toString, or function toString, and so on and so on. The same operation, but we are using different type. So we can use generics to avoid this kind of repetition. We can create a function called primitive to string, which takes any type as an argument and return string. So return type to string. Now, for example, we can create an array. We can call that array primitives, which is equal to number, boolean, string. And for each primitive, we can call a primitive to string method. So type primitive or console.logout primitive to string and pass a primitive. So let's run it. And as you can see on the console, we log out 3 to strings primitives. Cool. So we have learned some functions features such as function declarations, expressions, types, optional, default and rest parameters, generics.